Good afternoon, everyone. So this research is entitled Development and Evaluation of the Design of Mobile Solar Panel with Thermoelectric Generator with the following authors. So yours truly as the speaker of this presentation, Marcelo Sigontinas, together with Maria Leonora Teresa M. Aguilar, Palmaliter M. Domingo, and Jim A. Linda. So to begin this presentation, um, the Philippines, as a tropical nation, has a great potential for capturing solar energy through solar panels. However, from a series of experimentations and research, the solar panel's temperature, as the solar panel's temperature increases, the effectiveness of converting solar energy to electrical energy decreases linearly as well. So from the observations of the different research, indicates that in every 1 degree Celsius of temperature increase in solar panel, a drop of 0.06% of electrical efficiency. So in order to address this issue, we also have another related literature about waste heat recovery using thermoelectric generator in the application of diesel-powered automobiles shows that it improves the engine's performance. And the result also shows that the thermoelectric generator transformed 2.1% of the heat energy or waste heat energy from the diesel engine into electrical energy with a temperature difference of 300 degrees Celsius. So thus this study will develop and fabricate a photovoltaic thermoelectric system wherein a thermoelectric generator will act as a heat sink in absorbing the waste heat energy dissipated by the solar panel and converting it to electrical energy. This research will test the effectiveness of thermoelectric generator by adding also water cooling system at its cold side junction to increase the temperature difference. So this research will use different circuit configurations and will determine and test their effectiveness. So the process of doing this study starts with the design phase for the size of solar panels. So in this project, the researchers used five 12 volts 50-watt solar panel connected in parallel to maintain the voltage while increasing the current in the system. So this study uses 12 volts 20 ampere charge controller to utilize and regulate the voltage effectively from the generation of the solar panel, and it will also help the charging and improve the storage of the 12 volts 120 ampere hour specification battery used in this study. So in order to provide electricity to a load, the system will use a 500 watt modified sine wave inverter to convert the direct current into alternating current supplying a load. And six thermoelectric generators are used in this study, attached at the back of the solar panel with two circuit configurations. So the first connection is series parallel combination, wherein there are three thermoelectric generators connected in series and connected in parallel as well to another three thermoelectric generators in series. While the second connection is a series connection of all thermoelectric generators. So we don't use pure connection of parallel of all the thermoelectric generators because some of the thermoelectric generators doesn't have the same voltage generation. So if it is connected in parallel, then some of the thermoelectric generators will be act as a load. So the system will also use a buck boost converter to utilize and ensure that the output voltage of thermoelectric generators is boosted to meet the specifications of the device storage. So for the results and discussion from the bar graph, so it shows the comparison of the system with an ambient temperature at the as the source of the cold side junction of the thermoelectric generator and the water cooling system attached at the cold side junction of the thermoelectric generator. So the average power measured in the ambient temperature is 0.0428 while with a water cooling system is 0.0728 watts. And this results an improvement of 41.21% in favor with the water cooling system. While on the second And that was the result in the first circuit configuration, wherein a series parallel connection configuration. And for the second circuit configuration, wherein all of the thermoelectric generators are connected in series. So comparison as well with the ambient temperature as the source of the cold side junction of the thermoelectric generator, and water cooling system as cold side source of the thermoelectric generator. So the average power of 0.111 watts in the ambient temperature and 0.198 watts in the um, what with water cooling system. And it shows an improvement of 43.94% in favor with the water cooling system. And from the results between the two configurations, it shows that a power generated difference of 61.44% for an ambient temperature source in the cold side junction of the thermoelectric generator in favor with the second circuit configuration, where all of these thermoelectric generators are connected in parallel. So as the power generated difference of 80.59% in cooling with cooling system in favor with the second circuit configuration as well. Then for this bar graph, so it shows the power generated by the five solar panels. So it compares the system without thermoelectric generators connected at the back of the solar panels with the thermoelectric generators connected at the back of the solar panels. So the average power of 80.68 watts measured without the thermoelectric generators at the back of the solar panel, while an average power of 92.1 watts with thermoelectric generators connected at the back of the solar panel. And it shows an improvement of 12.4% more using a system of thermoelectric generator connected to the back of solar panel. Thus, in this study, the researchers conclude that based on the findings and series of trials, adding of thermoelectric generators to the back of solar panels boost power production by 12.4% compared to a solar panel alone. And compared to a series parallel connection, connecting thermoelectric generators in series is 80.59% more efficient at extracting electrical energy from the solar panel's waste heat. And the results also show that placing a water cooling system in the thermoelectric generator's cold side junction is 81.33% effective. Thank you.